Good afternoon, advanced algebra students. I hope you are having a fantastic day. We are hitting the second half of chapter 2 right now. As you recall, we did the first few sections of chapter 2 talking about parabolas, and then we did a detour learning about factoring. Then we came back to chapter 2 and talked about factored form of a parabola, and now we're learning something that is related to quadratic equations, but is a very particular topic called complex numbers. So it has to do when you have an equation with an x squared where the x squared is equal to a negative number. And we will go into more details later, but it's just a very specific situation that can come up when you're working with x squareds. So what you want to do for the top of your notes is write 2.4 and then write complex numbers and operations. So what I wanted to do is briefly just do a bunch of actually really kind of short, easy examples. But for our first example, I want to review what happens when we solve the equation x squared equals 16. When we solve this equation, we take the square root of both sides. And since we are adding the square root to a problem, we also add a plus or minus. So we get that x can be positive or negative 4. And of course that works because if I square positive 4, I get 16. But it is also true that if I square negative 4, I also get 16. So that's why we have two solutions here. Where we run into problems is when we have an equation that looks like, for example, x squared equals negative 9. I can still take the square root of both sides. I can still add a plus or minus. But now I have the square root of, we can think of this as negative 1 times 3 times 3. I do need to take out that 3, so plus or minus 3. But what about the square root of negative 1? And this is basically the essence of what our lesson is about today. The square root of negative 1 is a number that comes up so commonly that it actually has its own name. Just like pi stands for, 3.141579, blah, blah, blah. I stands for the square root of negative 1. So I would simplify this to be positive or negative 3i. So that would be the answer to that problem. So we're going to do more examples involving I, but that is the essence of what you need to remember, the most important part. All right, so let's just kind of make a note here. I equals square root of negative 1. It is also true that I squared is negative 1. So that would be maybe two important facts to just write down on your paper anywhere that you want. All right, let's do another very straightforward example and look at the equation x squared equals negative 72. We do want to take the square root of both sides. So we have x equals plus or minus square root of negative 72. But when we are simplifying square roots that are not perfect squares, we do need to do a factor tree and pull out pairs. So 72 can be written as 2 times 36, and 36 is a perfect pair, which is 6 times 6. So I can rewrite this radical as negative 1 times 2 times 6 times 6. Because if I multiply 2 times 6 times 6, I do get 72. Now, what do you think I can take out of here? I can take out the pair of 6's, and I can also take out, as we just learned, this square root of negative 1. So this becomes x equals plus or minus 6i times radical 2. So this is new, but in my opinion, it's not that insurmountable. It's fairly straightforward. All right, so imaginary numbers have an I in them, or I is an imaginary number. A complex number has I and also a real number component. So for example, let's just call this example 4. We could say 7 minus I radical 2. That would be considered to be a complex number. Or negative 6 plus 4i. So any number that has I and a real number component is called a complex number. Now, when we are doing operations with complex numbers, adding and subtracting is very straightforward. So let's see, this would be, I believe, example 5. Let's say that we're going to add 4 minus 7i to negative 11 plus 9i. This is kind of like just regular combining like terms. We're going to want to combine the 4 and the negative 11, and then we're also going to want to combine the negative 7i and the positive 9i. So 4 minus 11 is going to give us negative 7, and then negative 7 plus 9i will give us positive 2i. All right, likewise, finding the product of two complex numbers is very similar to something we've already done before. Let's find the product of 4 minus 2i times 5 plus 3i. This is kind of like finding, what is the product of x plus 4 times x plus 3? We just FOIL. So we multiply the two first terms, 4 times 5 is 20. The two outside terms, 4 times 3i is 12i. The two inside terms would be negative 10i. Now this is a little bit tricky part right here. Negative 2i times positive 3i would be negative 6i squared. We want to combine the like terms, so we have 20 plus 2i. Now remember that I squared is negative 1, so I'm going to take negative 6 times negative 1 to get 20 plus 2i plus 6, or 26 plus 2i. So again, the math there is fairly straightforward, but I just kind of wanted to run through, how to do the actual calculations. Now, there is something that comes up called complex conjugates. Complex conjugates. Complex conjugates are essentially two complex numbers that look the same except their sign in the middle is different. So let's say we have, for example, 3 plus 2i. The complex conjugate set for that, the remainder of that would be 3 minus 2i. So 3 plus 2i and 3 minus 2i, the first terms are the same and the second terms are the same, but the sign in the middle is different. Again, we would FOIL these. So 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i. And then this becomes negative 4i squared. Now, look what happens here. These two middle terms cancel out. So whenever you multiply two complex conjugates, that's always going to happen. So what you end up with is just a real number, because this is 9, and then the last term is going to be negative 4 times negative 1, or 9 plus 4, which simplifies down to 13. So anytime I multiply two complex conjugates, I will just end up with one real number. Okay, let's do just one or two more examples here. Let's just do, one more example here. Let's make this be, I think, example 8. We're going to take 4 minus 3i over negative 1 plus 2i. So here's the thing. There is a rule in math that we can't have an I in the denominator of a fraction. So in order to get rid of the I in the denominator here, I need to multiply the denominator by its complex conjugate so that I can turn the denominator into a real number. So I want to multiply top and bottom by negative 1 minus 2i. Negative 1 minus 2i. And then essentially, I multiply across the top and the bottom. Now we're going to FOIL each time. So on the first part, I'm going to have negative 4 minus 8i plus 3i, and then plus 6i squared. Notice the i's are not going to cancel in the numerator. That's fine. In the denominator, negative 1 times negative 1 is positive 1. And then I have positive 2i, negative 2i, and then negative 4i squared. Again, combining like terms, we're going to have negative 4 minus 5i minus 6 on the top. These cancel, and I'm going to have 1 minus negative 4 on the bottom. I got this negative 6 here from taking 6 times negative 1, because I squared is negative 1, and I got this negative 4 here. Let's see, negative 4 times, that should have been minus, let's see, let me see if I got this right. So minus 4 times negative 1, yeah, that was correct. Okay, so on the numerator, let's see, negative 4 minus 6 is negative 10 minus 5i. And then on the denominator, I end up with 1 plus 4, which is 5. Now, something kind of cool happens here. Notice that 5 goes into 10 and 5. This doesn't always happen. But in this case, this would then simplify down to negative 2 minus I. Negative 2 minus I. Okay, good job, you guys. I know that was a lot of kind of new information in some senses, but the mechanics of it should have just been reviewed. So I will look forward to doing more examples with you in the homework, and I hope you have a good night. Bye.